Okay, let's officially start. So, good afternoon, everyone. Welcome to the 16th ALASCA Tech-Talk. I am Matej Feder from D Nation Company, a founding member of ALASCA Association. And I'm pleased to moderate today's session. As usual, this meeting is being recorded. The recording will be available on YouTube a few days after the talk. Usually just visit ALASCA webpage /ALASCA Tech Talks, or simply search for ALASCA Tech Talk on YouTube to find it. Today's agenda, as usual, we have just 2 items on our agenda today. The main item is today's Tech Talk, followed by a question and answer section and discussion. Next, I will share some interesting events and news with you, and it would be great if you could also share some interesting news and events from your community with us. Lastly, I will briefly introduce the topic of the next Tech Talk, which will take place at the end of June. Let's proceed with the main part, which is today's Tech Talk. It's my pleasure to introduce our speaker, Dr. Miguel Caballer. He is a researcher at the Grid and High Performance Computing Research Group and the main developer of Infrastructure Manager software, which is today's topic. So he is truly the right person to lead this speech today. In today's 16th Tech Talk, we will explore what Infrastructure Manager is and how we can use it to achieve TOSCA-based cloud orchestration in deployment. So, Miguel, please take over the screen sharing, and stage is yours.
Okay, so let me share. Okay, can you see it?
Yes.
Okay, great. So okay, so let me introduce myself. As I said, I work at the high performance and computing group of the Technical University of Valencia. I'm the main developer of the Infrastructure Manager, and I'm going to talk about this tool, a TOSCA-based orchestrator and deployment tool that enables the users to make easier the deployment of any kind of virtual infrastructure on top of a wide variety of cloud providers. First, I start with a brief introduction. This is get from a blog that we put in the introduction. It's a quite funny way to introduce the problems that have the admins, the sysadmins, in order to deploy infrastructures in top of a cloud, because you have to configure the servers, create the networks, the security groups, configure all the software, and do it manually is a problematic job, because there is a lot of possibilities of hard misconfiguration. And this is the problems that solves the DevOps, and in particular, we will focus on the infrastructure as a code paradigm. So the infrastructure as a code paradigm is a process of provisioning computer data infrastructure using machine readable definition files, instead of only having physical configuration files and using different configuration tools. Using this kind of tools, you can automate the entire provision and deployment process of your infrastructure, so you can repeat the process many times and it gets much faster. and it avoids having errors because you can test it and make it reproducible. You can store the files in some version control software in a way that you have the history of the infrastructure evolution, so you can see when a problem is detected, you can debug what was the commit, for example, what caused the problem and roll back. You can also validate the infrastructure changes using some automated tests. And you can also create a library of reusable documents. So you can have some kind of libraries of the different kind of deployments, so you can reuse in increasing and evolving your infrastructure. And there are several tools that use this paradigm of infrastructure as a code. And the most well-known is Terraform, Puppet, Chef, in particular Ansible, that is the one that we have selected in Infrastructure Manager to use. So the Infrastructure Manager uses this principle, infrastructure as a code. So it enables to describe the full infrastructure, the full virtual infrastructure that a user or a community needs in order to deploy any kind of virtual complex infrastructure. So you can automate the provision and deployment of your tools, make it faster and more reliable than any manual process. You can use the very same definition template to provision the same infrastructure in different cloud providers. And in particular, we have adopted the Oasis TOSCA standard in order to describe the cloud topologies. So, the main definition of the infrastructure manager is a service that deploys virtual infrastructure on top of cloud providers. It uses RADL, that is the native language used by the IAM to describe the virtual infrastructures, but it also enables to use the TOSCA standard to describe it. So as we commented, we use this infrastructure as a code paradigm. And then the IAM automate the deployment, the software installation, configuration, and the update of the virtual infrastructures. And we have commented it also supports a wide variety of cloud backends, that's making the user application cloud agnostic, because we commented you can deploy the very same TOSCA or RADL document in different cloud providers without any changes. So the general view of the platform is it enables to deploy on demand any kind of complex virtual infrastructure with a precise software configuration that is required by the user. As we commented, it allows to deploy any kind of complex infrastructure with any kind of network or amount of virtual machines connections that are required. As we have commented, one of the advantages of using infrastructure as a code paradigm is that you can share this infrastructure, the descriptions, because are human readable documents. You don't need to have any prepackaged virtual machine image, so you can use any virtual machine image that you have available in your cloud provider. And I recommended the same complex virtual infrastructure can be deployed both in your on-premise cloud and in any public cloud that you have availability. So you have the ability to first test the deployment in your OpenStack or OpenNebula cloud provider, and then you can move it to an Amazon or Azure cloud provider to expand your infrastructure. So we recommended the IAM feature DevOps capabilities. We have selected the Ansible tool, and it provides a set of recipes for common deployments. And it also supports Cloud Init scripts, but we mainly use for very minor cases, because in most of the cases, Ansible is more powerful in order to describe the configuration of the topologies. The IAM works as a service and it offers several interfaces. The main interface of the IAM service is the REST API, but we also provide two client applications. One is the command line application, and the other one is a web-based graphical interface that we will show later in the demo. And it is distributed using the GPL3 open source license, and the source code is available in GitHub. You have commented, I suppose, our range of cloud providers. We have here a list of the currently available cloud providers. For example, in the case of public ones, we support Amazon, Google, Azure, Linode. We support OTC of the system. In the case of European cloud provider, we support Cloud Heat, Orange Cloud. In case of premises, we support OpenNebula, OpenStack, CloudStar, and VMware. We also support federated platforms as Fogbow and EGI Cloud Compute. And it also enables to deploy containers on top of container management platforms as Docker or Kubernetes. But the IAM is designed in a way that it can be easily extended, adding new plugins to new connectors in case that we need to extend this set of cloud providers. Okay, so the working scheme of the IAM is that the user provides the description of the infrastructure in RADL or TOSCA, and it processes this infrastructure info and it is deployed and configured. The RADL is the native language that this comes from resource and application description language. And it's a high-level language to define the infrastructure and specify a virtual machine software. Okay. And as we commented, also the OASIS TOSCA standard that enables to describe cloud topologies to be described. In the following slides, we will show simple examples of both documents. For example, this is the structure of general structure of a RADL document. You have several keywords, for example, the Ansible in order to specify an external Ansible host, network to specify the networks to be used by the nodes, system, that is the node, the virtual machines that specify the features of each of the components. They configure and contextualize that is used to define the several steps that are needed to configure the virtual machines. And finally, the deploy that specifies the number of how many virtual machines are required of each type. We will see an example. For example, here we see a simple virtual machine with one CPU and half gigabyte of RAM that is connected at one network that is defined also here, that you specify that it requires a public IP. In the configuration section, we add some simple Ansible tasks where this user is created. And finally, we specify that we only need one node of this type. We can see that with a very simple document, you can specify the deployment of a virtual machine. In the case of TOSCA, it comes from the OASIS group. We have adopted a simple YAML profile. It enables to specify cloud topologies, and it defines the interoperable the description of services and applications to be hosted in the cloud. And it enables the portability across different cloud orchestrators, because there are another several tools that is also adopting this TOSCA standard. As we will see an example, as you can see, is a bit more verbose than in case of RADL. In this case, we have this import section when you can add some types that can be imported into this YAML document. We have some input section where the user has the ability to change the value. For example, in this case, the default value of the RAM memory is 1 GB. Here we define a node, the type Kepler, that is a software for workflow composition, that it is hosted on top of the Kepler server. That is defined here. That is a compute node that requires a public IP, that opens this port, the PNC port, that has, it requires one CPU and the amount of memory that we have specified as the input. And he will also specify the different, the properties required for the operating system that it requires an Ubuntu Linux 18. And it also provides some outputs that are finally the values that are required the user to access the platform. And in particular, it provides the public address of the Kepler server and the credentials, in particular, the credentials, the SSH credentials that are provided by this node in a way that the user can access the node. So, but how works the containerization in the case of the IAM? The IAM only needs that one of the virtual machines has a public IP. And it's a Linux-based virtual machine with a public IP with the SSH connection open. In this way, the infrastructure manager installs and configures Ansible in this first node. And once it is configured, the contextualization agent is launched in this virtual machine. And it is the one that uses Ansible in order to configure all the different virtual machines. In this way, we only need one of the virtual machines to have SSH access and public IP, and the other virtual machines can be private and has no external access without any issues. Recommended, the IAM also has two different client tools. In particular, we have the IAM client, that is the command line interface tool, where all the functionality of the IAM is available. And also the graphical user interface, that is the web application that we call the IAM dashboard. It is publicly available. We have an instance that is working for the EGI Federation, that is im.egi.eu. You can log in with any EGI check-in account. It is integrated with the EGI PPDB in order to get the information about the virtual machine and the sites of the EGI Federation. But you can also use any other cloud provider, as we will see later. It enables to easily deploy infrastructure from our web browser for non-advanced users. It has a set of curated TOSCA templates, and it has a wizard-like composition of templates in a way that you can select a set of templates in order to compose, and then finally add the input values in order to tune the configuration. We will see later a demo. We can see here a set of screenshots, but so it is designed for non-advanced users in a way that with only a set of clicks they can deploy infrastructures, and they select for this set of curated TOSCA templates that has been prepared for non-advanced users and for a set of platforms that are interested in the scientific research. The IAM service also provides a set of APIs. The main one is the REST API that follows the Open API specification. Here you have information where you can see the full API and all the documentation in order to access it. Well, this is a figure of the IAM architecture, but I will not enter in too much detail. I have mainly comment that there are several tools that we can sell, we can comment that as an ecosystem that we use in order to improve the IAM functionality. One of them is another component that has been deployed in our group, that is Clues. That is an elasticity manager that it enables to add or remove nodes in a virtual cluster in an automatic way. For example, we can create an Slurm cluster or a Kubernetes cluster where the nodes are added or removed depending on the workload of the cluster automatically without any user intervention. The IAM also uses Vault and in the IAM and the IAM dashboard to securely store the credentials of the cloud providers because they are required to be stored in order to be provided for the IAM. We commented we use Ansible for configuration. We connect to IPPDB in order to get EGI sites and virtual machine image information. And the last addition that we have made in the last project where we have participated, that we will comment at the end of the presentation, we have added cloud continuum support in order to be able to access edge devices. And we use the OSCAR, that is another component that deployed in our group. And we can also access Kubernetes clusters. So, and this figure shows the evolution of the IAM in the last years. Yes, it started in one national project named Code Cloud by the Spanish ministry. And it has been evolved in several projects. One of the most important was in the Data Cloud, where the TOSCA support was added. And we are currently working in several European projects where we are adding support in order to create TOSCA recipes in order to deploy several applications, several infrastructure for research for several use cases. And also we can comment the AI sprint that has just finalized it some months ago, where we add also this support of this edge capability for the infrastructure manager. And now let's go to see a demo. I will change to the video that it will show how to deploy how to use the infrastructure manager dashboard to deploy a relatively complex infrastructure with a JupyterHub on top of a Kubernetes cluster with a set of different working nodes that some of them has GPU support. So, okay. Okay. Can you confirm that you see the video?
Yes, I see it.
Okay. Oops. So this is the landing page of the infrastructure manager. As we have commented, you only need to log in to the EGI check-in in order to have access to the IAM dashboard. Then you can see here the list of the different TOSCA templates that you can deploy. But first, we have to create the cloud credentials of the site that we are going to access. As you can see in the list of my credentials, I have EC2, Acer, Cloud and Heat, Google Cloud, OpenStack. And in this particular demo, we will use an EGI site using the training BO in order to deploy the resources. But you can do exactly the same with any of the cloud providers that you have there. Another interesting feature of the IAM dashboard is able to add your SSH key in a way that it is injected in all your virtual machines, in a way that automatically you can have access to your virtual machines. I don't know if you can see correctly, we have selected a Kubernetes cluster, and we will add a JupyterHub and a new type of working node in order to have this heterogeneity. Now, the user has the ability to tune the infrastructure, setting the input values of the TOSCA templates. So we are setting the feature of the front end now of the first set of working nodes, where we can only have one working node. Then we can configure a basic set of values of the Kubernetes configuration, where we are going to start the third manager in order to create a valid set of SSL certificates. In this case, we are using a tool of EGI provided by the ISAS Institute in order to add a DNS name. So we create this DNS name that will be assigned to our virtual machine. And then we will see later that we will use this name with a valid SSL certificate to access the application. We also can configure some details of the Jupyter. And now we will set the information about the second set of working nodes. In this case, we create only one also. But in this case, we are going to specify that we require one GPU. And we want to also install the NVIDIA support in order to give access to this one. So finally, we select the cloud provider. In this case, we will set the testnet site. But finally, we will use Horseman, that is our cloud provider, because this is now the currently site that only has the GPU support that we require for this demo. And finally, we set that we require an Ubuntu 22 image, and the IAM starts working. So in this moment, the IAM is start deploying the virtual machines, creating the security groups, the volumes, and all the required components. And when it is running, it will start the configuration phase. As we said in previous slides, we configure Ansible and launch the contextualization agent. Now we have updated the DNS name to set the current IP. And then we only have to wait a couple of minutes. In this case, it's about 15 minutes because it's a quite long recipe. And then we will get the outputs of our application, where we can access either the Kubernetes dashboard in order to access directly the Kubernetes resources, or the JupyterHub endpoint in order to access the final application. Here we can see that we have the different working nodes that we have selected. And you can see also that we can make an SSH connection to the node. And as we have added, as I have added my SSH key in the Kubernetes, in the IAM dashboard, I directly have access to it. I don't need to download the key. So we can see that in the case of the second node, we see that the NVIDIA GPU has been configured and it is available for Kubernetes. And we can see that in the first working node, the GPU is not available, as we have selected in the IAM dashboard at the beginning. And now finally, we will see how to access the Jupyter instance. Probably this part is not so important. And here, mainly, we will show that we will launch a Jupyter notebook with GPU support. And we will see that this GPU is available from JupyterHub. Logically, as we have requested GPU support, this pod has been launched in the second working node, that is the one that has the NVIDIA support. And finally, we'll use an application that uses artificial intelligence in order to compute an Alzheimer application. I will not enter in much details because it is more application specific, and we'll skip a bit. But basically, it makes several compute steps, but some of them require GPU. And finally, you get the image of the brain where you can see the final results. So once we have finished our computation, in case that we don't need our virtual infrastructure and we don't want to use it more, and we want to release the resources in order to avoid additional costs, we can delete, and all the resources will be deleted from the cloud provider. That's releasing on all the resources, avoiding costs. Okay. So going back to the presentation.
Aquí estamos de nuevo, un año después, en la zona de Desert. Esta vez Fran y yo somos los veteranos. Y los...
Sorry, because YouTube is launching me ads. Okay. So as we have shown in the previous slide, the IEM was used in several European projects. I briefly comment the most important one in the last years, and on some of them that are currently working. In the case of AI Sprint, that have just finalized, and the IEM was used to deploy virtual infrastructure required for executing AI models along the computing continuum. In this case, we used to deploy Kubernetes clusters and InfluxDB cluster, Oscar clusters, and also to deploy Oscar services on top of existing OCAS clusters that have been manually deployed in the edge. In the case of the DTGO project, the IEM is used to deploy customized Slurm-based clusters that are used to scientists to train the computing skills required before executing in this very similar environment in a real supercomputing, in particular the Mare Nostrum one. In the case of the Intertwin project, this is currently ongoing, the IEM is using to deploy a different set of big data analytic tools that are required for digital twins. In particular, have created some TOSCA templates and resized for several tools as Kafka, Airflow, MLflow, Horobot, and Galaxy, etc. And the last one that we will comment today is the AI for EOSC, that it is used to deploy pre-trained AI models from the EOSC marketplace in different cloud platforms in a reproducible manner, in a way that you can deploy these pre-trained AI models in any cloud platform that you have availability. So this is basically the end of the presentation. If you want more information, we have here a set of links. Basically, the first one is the IM info webpage. There are several videos in YouTube where there are some demos of the one that we have shown in this ALASCA Tech-Talk. We have the the Docker images in the DockerHub and GitHub container registry, and all the source code is available in GitHub. So finally, if you want more information, you can contact me, Miguel Caballer, or my colleague Germán Moltó, using one of these email addresses. So this is the end. So
Yeah, thank you very much, Miguel, for the interesting and informative presentation. Now we have time for questions and answers. If anyone from the audience has a question for the speaker, please raise your hand, speak up directly, or drop the question into the chat meeting, into the meeting chat. So just ask in these ways. At least I have one, because I had the luck and I had a hands-on experience with infrastructure manager in the context of AI sprint and integration into the Krake software. So, and I'm wondering, my question is, you mentioned that you support or infrastructure manager supports a lot of cloud providers, public or private clouds like AWS, Google, OpenStack, for example, and the interface, the manifest on the when you start with the infrastructure manager is TOSCA-based or RADL, as I understood correctly. And my question is about how you can and how the infrastructure manager maps the large cloud provider API into the, for example, Tosca receive. Basically, does the infrastructure manager somehow generate the schemas for AWS, for example, or how the mapping between the Tosca or the RADL manifest is done in infrastructure manager to speak with particular cloud provider? Thank you.
well, there is no, let's say, a translation as it is, because it is basically uses the RADL, that is the native one, because the way of work of the IAM first get Tosca, translate into RADL, that is the native internal way to store the information in the IAM, and then uses this information in order to transform into a set of API calls to any of the cloud providers. And all of them are supported with all of them are supported with more or less using the same functionality, because more or less all the cloud providers support the same. So we have a set with a common layer for the cloud providers, and we transform this Tosca or RADL document into a set of API calls into our internal compute layer, and then this set of plugins transform these internal API calls into a final API call to the final cloud provider. In a way, this is a way we enable to add different cloud providers, adding this middle layer, in a way that adding this set of plugins, you can add new cloud providers a quite easy way.
Okay, thank you for answering my question. Danilo, I have one also, so feel free
Yeah.
to raise your
So
voice.
okay, thank you. So I'm Miguel. Actually, you mentioned that recently you extended to manage also edge systems and computing continuum. Can you summarize which were the most important challenges to face? I mean, which were the difficulties in the implementation and extension?
Well, the main challenges was to see what is a common interface in order to access this edge component, because in the case of the cloud, they have more or less the same kind of APIs in order to create virtual machines. So in this case, the functionality is mostly the same in all of them. But in the case of the edge components, we don't have this ability to create virtual machines. So we must assume that the components that have been already deployed, and in this case, we have to add this support to an already deployed components, and we have added the support for the basic one that we only have an SSH connection, and in this case, the IAM added the ability to access BSSH and configure the software that is required. And we also added the support for a sprint in the case of OSCAR clusters that have been already deployed, and only deployed in this case the OSCAR services in order to add the functionality, the serverless functionality that OSCAR provides to the final users. And we also working to add a similar functionality in order to create containers on top of directly of an existing Kubernetes cluster that we are assuming that is also installed in these edge components.
Thank you. Thanks a lot.
Thank you, Daniel, for your question. We have another one in the chat. Rene is asking, can you say anything about opportunities and threats, risk and complexities in relation to the decentralization, for example, blockchain, like DePIN in relation to TOSCA?
Well, I'm not an expert in blockchain, so maybe I'm not the best one to answer this question, but the case of TOSCA is the way that we are using it is used to describe cloud topologies in order to deploy virtual infrastructure. So in case of you require some kind of a blockchain infrastructure that requires the deployment of a set of distributed virtual machines in different cloud providers, it can be described in TOSCA, and it can effectively be deployed using the infrastructure manager. But I cannot say any more specific to this kind of tools because I don't know exactly the internals of these tools.
Yeah, Rene, thanks for your answer, Miguel. Another question in the chat is from our team. How TOSCA is designed to handle structural platform differences. It means when certain cloud provider does not have a concept of security groups while others do. This is an abstract example.
Yeah, so the infrastructure manager tries to map all the information that is described in the TOSCA as much as possible to any cloud provider. So in some cases, maybe there are some kind of functionality that it is not provided directly by the cloud provider. So maybe it uses the most similar one to provide the requirements specified by the user in the final cloud provider. But really, in the last years, most of the cloud providers are are providing almost the same functionality with very few changes. So this kind, for example, in the case of security groups, for example, all of the cloud providers has almost the same concept. Mainly, I don't remember now exactly, but in case of Azure, for example, it is not called security group, but it is providing some similar functionality in order to provide or not access to different ports that has to be open. But this is finally the functionality that is provided. The user does not know about security groups. The user in the TOSCA specify, I want to access these ports. I want the port 80 and 443 to be open in order to access my HTTP and HTTPS application, and I don't care if there are security groups or another concept. The important part is these ports are open and the rest are closed in order to avoid exposing my application.
Does it answer a question, Artem? Yes and no. Could you please specify why no, or do you want to discuss it further or not? Yeah, Artem mentioned that this requires certain level of abstraction, which is true, but this is why the infrastructure manager exists, isn't it?
Yeah, this is first. We have the first level of abstraction is TOSCA, then it is translated to RDL, what more will have all the information there. Then this RDL is transformed this into our internal cloud layer set of called APIs. And then this set of APIs, called APIs for the internal cloud API of the IAM, are translated into the final APIs of the cloud providers. Yeah, well, I see now the comment about the database as a service. Currently, the IAM is working at the infrastructure as a service level. So it is not providing currently the ability to launch a database as a service. It enables to deploy a virtual machine and configure then a database there, but not launching, for example, directly an RDS service in case of Amazon or similar in the other cloud providers.
Yeah, thank you for answering the question, Miguel. Another specification from Rene in the chat. Rene mentioned or specified the context for his question with disclaimer for full transparency that he has a very small but still some stake in this. Unigrid.org, which is building decentralized shared internet, and he's wondering how great TOSCA would be to enrich the ecosystem in facilities, since it seems feature rich and especially because it is cloud agnostic. Could you comment on this, Miguel?
Yeah, this is one of the reasons that we decide to use TOSCA, because first of all, because it is an OASIS standard, because it's a standard, and because it is cloud agnostic. So in a way that you can define a TOSCA template without any specificity of the cloud provider. But TOSCA has one thing that it can be a good thing, but it can be a problem. It is very extensible in a way that you can add new nodes to the set of normative types that are already existing. It is good because it enables you to add new functionality to the one that is defined initially in the standard, but it may cause that if you define a lot of types that are not normative, you are using TOSCA, but you are so far from the normative, from the original types, that it's very difficult that this will be adopted by any other or TOSCA orchestrators. But I think that for your case, I think that using TOSCA can enrich your ecosystem. You can, because as I said, that it is also extensible. It enables you to define a lot of features of TOSCA topologies.
Yeah, thank you, Miguel, for answering the question. Does anyone have any further questions? Okay. If there are no further questions, thank you once again, Miguel, for an interesting presentation and for answering all the questions. Now let's proceed with the next slides with the news and events. So I will share again my screen. Screen sharing, screen one. Okay, news and events. So I want to mention just two events. First, the Great SCS Summit, which was followed by Open Infra Day Germany. These two events took place already 2 weeks ago, and I'm pleased to share the success of Alaska at these events, where we were very active and represented by several team members. Importantly, the Alaska projects Krake and Yaug were presented there with a nice success. The next event is upcoming, the Alaska Summit 2024, which will take place on October 29 and 30, 2024. So save the date. For your information, Alaska team is currently reviewing proposals to finalize the agenda. All contributors will be informed very soon about the acceptance of their submissions, so stay tuned. And I'm really looking forward to this event. Does anybody have any news or updates they would like to share with us, with the community? If yes, feel free to speak up now, or write to the chat. It seems it doesn't be the case, so stay tuned. Here is a brief overview of how you can remain connected with Alaska. So first, check out our upcoming events on the Alaska website, alaska.cloud/Alaska Tech-Talks. Subscribe to our mailing list at hello@alaska.cloud for monthly reminders and calendar invitations, and watch talks on our YouTube channel. Find for Alaska on YouTube. So stay tuned, stay informed. Last but certainly not least, mark your calendars for our next Alaska Tech Talk scheduled for June. Save the date, June 28th. Felix from SCS, Sovereign Cloud Stack, and Ilya from Cloud and Heat Technology will be joining us to share insights from Yaug and constructing SCS compliant cloud infrastructure. So thanks for being here today. Big thanks to our speaker Miguel for insightful talk, and to all of you, to our audience, for great questions. Stay connected with ALASCA, and see you next month. See you. Thanks a lot, Miguel. Bye.
Thank you for inviting me for this talk. Bye.